Okay, so today I will be talking about linked lists, and you can open up your IDE if you want to code along, but first I'll start off with some kind of more conceptual stuff. So if we take a look here, I just have Violet open with some boxes, and these are meant to each represent list nodes. So this would be a single list node, this would be another list node, this would be another list node, this would be another list node, and this would be another list node. So if you don't already know, the way that linked lists work is that you have a bunch of list nodes that are chained to each other with next references. So for example, each list node would specify that, you know, I have a next list node. So this first list node specifies that, hey, my next list node is this one, and then this list node specifies that my next list node is this one, and then this one specifies that its next node is this one, and that's just specified by these arrows here. That's how I'm diagramming it out. But in the actual code, it would be a field, and I'll show you that later. A list node also generally has a value stored in it, and so that could be anything. You could have a linked list of strings, linked list of integers, of any data type, really. This temp box is just for a temporary reference to a variable, and you'll see why that's handy in a little bit. So when we have a linked list, also this last node, it has a next reference, but it points to null, so it doesn't actually point to list node box. And that's handy because we can do something like, if next is null, we'll know we're at the end of our list. So what we can do here is we can start with our list, and we can say, hey, let's say I want to switch, I want to add a new thing to the list. Okay, so I'm going to give you a list node. I'm going to call it 8. I'm going to give it 15. And I'll say, hey, I want you to add this to the end of the list, right? So what's going to happen is that we're going to start at the first list node, and we're going to say, okay, next. Let's go to the next one from here. Okay, let's go to the next one from here. Okay, let's go to the next one from here. Okay, let's go to the next one from here. Okay, let's go to the next one. Oh wait, the next one is null. Okay, let's just add 15 at the end here. Oops. Select them all, move them all over. And let's add 15 right here. So like that, you can just add something to the end of the list. Let's say I want to add something to the middle of the list. And this is when it gets a little bit more complicated, because you have to start thinking about the Java garbage collector. Let's say you want to add 7 between 5 and 8. And your linked list doesn't have to be sorted. I'm just making it sorted just so I can, I guess just so it's easier to visualize that, you know, this is after this. But it definitely doesn't have to be sorted. 7 could go in here or anywhere. But I'm just going to put it between 5 and 8. So the way you would do this now is, okay, so you might be tempted to say, okay, well, let's get up to 5, and then it's like, okay, we're on 5, so we want to add it as the next node. So let's just take this arrow. Oopsies. Let's take this arrow, and let's point it to 7. Okay, now we run into a problem. We don't have 8 stored anywhere, so now it's like 8 isn't even there, right? So now we lose this whole part of the list because we have nothing connecting to it. And this is where a temp variable comes in. So if you remember, we start off like this, where we have 5 connected to 8, and we're saying that we want to connect 7 in between 5 and 8. So what we can do to make us not lose this 8, 10, 15 part of the list is we can take an arrow. We can take an arrow from the temp variable to 8, and this lets us store 8 in a reference, because a variable has to be stored in a reference for us to be able to, an object has to be stored in a reference for us to be able to access it. So you can see, actually, so the 1 should be stored in head. This would be the variable name for it. You can call it root, head. Those are both names for the same sort of thing. You'll see both names quite often. So you'd have head pointing to your 1, and that's how you keep track of that you have this list. And then 1 has a reference to 3, 3 has a reference to 5, has a reference to 10, 8 and 10, and 8 has a reference to 10, 10 has a reference to 15, and that's the list stays in memory. If one of these references is removed, everything after it in the list just magically disappears. Well, it's not magically. What happens is the Java garbage collector comes through, and it takes it and it gets rid of it out of RAM because you can no longer access it anyways, so there's no point in keeping it in your RAM. It's just a waste of space. So what we want to do is we want to avoid the garbage collector getting rid of this 8 while we put the 7 in here, right? So what we can say is okay, we can set a temp variable to 8. And that's one option. And then we could take this and we could say 5 is connected to 7, and then 7 is connected to, let's look at what's in the temp variable, 8. Okay, so that's one option of how you can go through it. A little bit of a more efficient option might be to go, okay, so we're at 5. Now let's set the same thing that 5 points to, let's say 7 points to that too, and then we can move what 5 points to 7. And remember, we have 7. In this case, it would be stored in the method parameter. So we keep a reference to that. So we don't have we don't have to worry about losing the 7 because it is stored in a variable. So that's how you can add something to the middle of the list. You just have to make sure you point the reference to the node in front, and then you pull it in after you've already connected the node in front to it. You can connect the node behind it to it. Otherwise, you would just lose this whole part of the list, and that would be pretty bad. So now another thing we can do is we can remove a node from the list. So how would we do that? We can go through the list and we can say, okay, I want to remove 5. So let's go 1, 3. Oh, the next node is 5. Okay. Now how do I remove 5? So you might be tempted to just go, oh, okay, let me just delete 5. But now you notice, now we have a problem. 7, 8, 10, 15 are all gone, right? We have no connection to them, and that's a real issue. So what we can do instead is point 3 directly to 7. So we can point 3 to 5's next, basically. So we can say, like, it would, in code, it would look something like 3.next is equal to 3.next.next. And so we can just point that to that, and we can get rid of our 5. And boom, it's gone. And we never lost the rest of our list, and our 5 is just gone. So that's perfect. Something else you might see is adding an element to the beginning of the list. So let's say we want to add 0 to the beginning of the list. We can go through and be like, okay, we have our head reference. How do we add to the beginning of the list? We can say, okay, this points to the same thing that the head reference points to, and then let's just point the head reference to this instead of pointing it to the 1, and now all of a sudden we have a 0 at the start of our list. We can add things to the end of the list. We can add things to the middle of the list. We can remove things. We can remove the beginning of the list too, for example, and that would be the same as what we did earlier, but we would just use the head reference, and we would say, okay, head.next is equal to head.next.next. No, sorry, head is equal to head.next in this case. So we get rid of that, and now the head points to the 1, and the 0 is gone out of memory because we lost our pointer to it. Let's see. I think that's all of the major operations. There's things you can do, like, for example, reversing the list, and all of those follow like a similar sort of trend. So for example, you can reverse a list by taking this temp variable, and we can let's say we want to reverse a list, right? So we can go every time we would go take the temp variable and we would point it to the next thing to store this, and now we would say here actually I think this will show it much better than this visualization would. I think this is a good visualization of it. So for example, this could be how you could reverse a linked list. So you can see what's happening here is, let's restart the GIF from the beginning. So the head and the current point to the same thing. Then we point the next reference to that, and the previous reference was at null, and then it moves up to this as the next reference moves up, and the current reference moves up, and then we point back again, and then we still have this next node stored, and then current moves up to there, then the next reference moves up, and we point current to previous again, and then we just keep doing that. And you can see what the code snippet would look kind of like here, and this is obviously not Java, but it's pretty readable. Okay, so that's how you would reverse a list. And if that doesn't make sense, I would recommend just rewatching that GIF, and it'll take a bit for it to just kind of click, but then once it clicks, you'll get it. So what we're going to do now is we're going to actually make a linked list, and we're going to make a really simple linked list, okay? It's just going to be a collection of nodes with no real methods. So all we need for that is we're going to say public class list node, and we're going to make a list node we're going to make the next variable be of list node type, and we don't have to set that to anything, and let's make it public. And then we're going to say, let's just say int val, and actually let's make that public too. See, normally you probably would want getters or setters for this, or you would have it be encapsulated inside of another class, and that would make it alright. But in this case, we'll just make it public because we're not too worried about that. Hi. So we're just going over linked lists. We just started the coding part. So all I've done so far is add a next field and a value field. And I'm doing a very stripped down version of a linked list. Normally for a linked list, you might want to store a head reference here instead, and then you'd have another class inside, and that would be your list node class. And you would have a class outside called your linked list, and your list node would look something like this still. But we're going to do it this way just because we want to work mostly just in the main function and not actually create any functions, just so we can play around with it a little bit easier. So what we're going to say is okay, list node head is equal to a new list node. And I want to add a constructor for this. So list node, and constructors are public, and let's say value is equal to val. So we take in an int val, and it's this dot value is equal to val. Okay, so we take in a value and we set it there. Just because we want every list node to have a value. So we'll say 3, and we'll also set the next equal to null by default. Okay, so, and then we want the heads next to be equal to a new list node of 4. So, if you're confused about what we just did, basically what we did was we made a head reference. We created a list node with a value of 3, and we stored it in the head reference. And then we took another list node with a value of 4, I believe. Yep, 4. And we said that the 3 node points to the 4 node. Okay, so now we have a chain of 2 nodes. And let's put a third node in. So how could you do that? You can say head.next.next is equal to new list node 5. Why does it work to just chain these next like this? Because basically when we say head.next, we're looking at this list node, and then we can just put a .next on top of it, and then it goes to the next list node. So it goes to the next, like the next variable of this list node. So in the case that we just do head.next, we're looking at this 3's next field, and then we're setting that to be this list node that contains a 4. And then when we do head.next.next, we're looking at this 4's next field, and we're setting that to be a 5. And if you remember, originally they're nulls, and we're changing them to 5's. So this 5 has a next field of null, and we can actually see that if we go, we can print head.next.next.next, and let's see what happens there. I think we can print out null. Yep, okay, we can see that happens just like that. We print out null, and if we were to get rid of that and take a look, oopsies, got rid of a parenthesis. To get rid of that and take a look, we get this list node thingy, and this list node thingy, it doesn't mean a whole lot, and that's because we don't have a toString. So if we wanted to do that, we can just do a public toString, and my IDE will automatically make it look nice and pretty for me, but basically what we're saying is whenever we print out a list node, we wanted to print out its next and its value. So we can see that the list node with the value of 5 has a next of null, and if we were to get rid of one of these nexts, we can see that the list node with a value of 4 points to a list node with a value of 5 that points to null. So we get this really nice view of what's going on. And if we want another way of looking at this, can be to go use the debugger, and this is a really good tool that you should get used to using. And we can see, okay, so the head reference at before this line runs, it points to a list node with a value of 3. Then let's step, oopsies, wrong one. Let's step, oh, I did it again. Okay, let's step over that. Okay, and let's see. Okay, so now our head points to this, and this points to null. So we have a list node with a value of 3 pointing to a list node with a value of 4. And if we go over again, and that list node now points to a list with a value of 5. So you can see that would be a really good way of debugging when you're in the middle of a project, you're writing all these methods, something stops working, and you're like, oh no, what happened? You can quickly check with the debugger and see where things aren't pointing to what you expect them to exactly. But I really do recommend, if just checking the debugger doesn't fix the issue, then you most likely have a logic issue. And so for your logic issue, you want to go through and you want to kind of draw it out, and you want to make sure that you really do always have something pointing to every part of your list, because that's going to be most often where you slip up when you're making a linked list, is you're going to somehow lose a part of your list. And it happens a lot. You have to be really careful about keeping track of everything. So just whiteboard it out, write your temp references like I did there. and just make sure that everything is exactly where you would expect it to be. So let's actually implement one of those methods here. So here, let's say I want to do a add to the end of the list, right? So what's one option for how I could add to the end of the list? Add to the end of the list. So one option for doing that is we know that the last element in the list is going to point to null. So what if we did a while whatever the node I'm on dot next is not equal to null. Let's keep going. Let's move the thing forward one, basically, right? So let's say while this node, and let's set current equal to head to start it off. And we need to specify that that's a list node. Okay, so what is this doing step by step? Let's actually try it out. Let's give it a shot in the debugger. Let's see what's happening. Okay, so we have this current node, and we can see that the current node is the one with a value of 3. We step into this, and we step into it again. Okay, so now on our second iteration, it's at the node with the value of 4, and then it's the node with the value of 5, and then you see how it skips the loop and it goes to the end. That's because it's gotten to a node with the next value of null. We can see that, so now it's at the end of the list. So now current represents this node, and this is the last node that we added to the list, so that makes sense. So now what we can do is this current dot next is equal to a new list node. Oopsies, not a new list. A new list node with a value of 6. So what is this doing? This is just putting 6 at the end of here, and you can see how just writing all these dot nexts manually can be a nightmare. And when we have a list of unknown length, we don't know how many dot next to write. So if we use a quick and simple loop like this, we can just get a pointer to the end of the list really easily. So now if I let's say I want to run sorry, I always do PSVM, but it's I want to print out my head. I want to just see my whole list. So let's print it out and let's see what's happening here. Okay, so you can see that we have a oopsies, we have another print statement here that we don't need. So we can say that we are getting a list with a node that has a value of 3 pointing to a node that has a value of 4 pointing to a node that has a value of 5 pointing to a node that has a value of 6 pointing to null. So this is probably one of the simplest ways of getting to the end. You can also store an end pointer and keep updating that, kind of similar to how you store a head pointer. And that just really depends on your implementation of your linked list and how you want to do it. Just for this, I'll only store the head, but you can definitely also store the end. Okay, let's say I want to add a node to the beginning of the list. So I have a new list node of 2, and I want to add it to the beginning of the list. So how can I do that? How do I just delete a line? Okay, that works. So I want to add it to the beginning of the list. One way to do that could be let's store this in a reference here. List node to add. Okay, so we have to keep this stored in a reference somewhere. So it's stored in the head reference, but we want to move this into the head reference. So where does this node go? This node goes in this thing's next. So we say node to add dot next is equal to head. And then we say head is equal to node to add. And that might be a little bit confusing because you might be thinking, what just happened there? We just set the node to adds next to head, and then we set head to node to add. That sounds kind of weird. But if we actually take a look with the debugger and see what really happened, we can see that it does make quite a bit of sense here. And this is why the debugger is a really handy tool, because you can see what your code is really doing. So we can see that we have a node called node to add, and it doesn't have a next, and it has a value of 2. And we have our head node here, and it has a value of 3. So what happens here? So when I say node to add dot next is equal to this. Okay, so what you can see happened here is actually next is pointing to this object, the list node at 799. You can see that here is node to add dot next is list node 799, and that has the rest of the list just like we would expect. So now what we can do is we can actually move this next, this head reference, and we can say, okay, I want it to actually have this 2 in it, because this 2 points to the whole rest of my list, right? So we can move the 2 to the top without losing any of the list now, because of just this one line. So we can see that that's a really easy implementation. And there might be edge cases and things you have to worry about when you're doing it yourself, but when you're taking user input or client input or something, you would need to check stuff and make sure everything's okay. But it's not really something too difficult to do. And if you remember, it's the exact same thing that we did in our UML. Implemented in the exact same way. What we did basically was we took this 2 node and we pointed it here, and we knew to point it here because this is the node stored in the head reference. We're not pointing it. You might be tempted to think that we're pointing it here, but that's not what's really happening. We are pointing it here. So that's just something important to remember. And then this head holds this instead when we're done. So the first step is ends. So when this line ends, these two both point to the same thing. And by the end of the execution, what we have is this head pointing to the 2, which points to the 3, which points to the 4, which points to the 5, which points to the 6, etc., etc., etc. And that your linked list can be, as long as you need it to be without running out of computer memory. So that's pretty much the basics of linked lists. Does anyone have anything that they want to see demonstrated in particular? Or any questions at all?
No, none from me.
Alright, awesome. Well, if you think of anything, you can always ping me in the Discord. I will respond as quickly as I can. And that is all of the material I have for today. Thank you guys for watching, and I will see you all next time. Thank you.